And then, yeah, if any of you have specific questions you have about Module 5, I'll be kind of starting at the beginning, probably covering stuff from A and B, but I'll focus a little bit more on A. So we'll be looking at quadratic functions, quadratic inequalities, rational and polynomial inequalities. So there's other stuff about polynomials in section 5.6, looking at zeros. We'll look at some math lab graphing tools. As usual, this is being recorded, so you can go back and view the recording later if you remember, talk about something that was in 5B and you weren't doing that yet or whatever. And then, of course, you also have the lectures Friday and Saturday that you can attend and watch recordings of. You should have the schedule that gives kind of the topics that are going to be covered, but is also where you find the recording links. So I'll leave this screen up for a little bit for in case anybody can't hear me. But yeah, I guess I should talk while it's up there so that it's clear that there is sound. That's probably long enough on that. As usual, you can participate using the chat, using the reactions, or even turn on your microphone and speak. So I'll try and keep an eye on that, especially on the chat and on the participants list where I can see if you're raising your hand or whatnot. So there's that, and then yeah, we'll have the feedback link that we'll come back to at the end. So the first thing I wanted to point out real quick is if you look at this formula sheet, so you had just a few things that applied on on test 1. Is pretty much just these first 4 things that had anything to do with test 1. And then the rest of it pretty much isn't going to come up until we're in chapter 6 and like the later part of starting the 6.3. So this chapter 5 stuff, chapter 4 stuff that we're doing here in module 5, none of that is going to be on the formula sheet. So anything that's formulas, equations, processes, all of that, you won't have any notes or anything to help you on the final exam with doing those. So make sure that you're learning them to where even as you're doing the homework, if you're doing a problem and like using a lot of the resources, a lot of like, help me solve this and show me an example and looking stuff up, and then you get it right, maybe ideally in a world where you have unlimited time, you go back and you do it again, trying to do it without the resources and do it again until you can, feel like you're really actually confident doing it and not depending on all of those perfectly good resources, but not going to be available to you. So if you can only do it with those, then maybe you're not quite at the level that your score might indicate. So just kind of general tips, but we're going to look at some specific questions from starting with the 5A homework. So starting with number 13 here. And so this is a graph. We're given this quadratic equation and we're looking for the vertex, the axis of symmetry, the concavity of the graph, and then using a graphing tool. So first up, just some general things. So this is what we call vertex form for this equation. I'm going to go ahead and mute you, Trayvon. If you have a question, should say, do you have a question, or was that just okay? There we go. All right, so this is what we call vertex form, and this is an important, really probably for you to memorize vertex form for a quadratic equation. So it's y equals, or f of x equals, and it's a times x minus h squared plus k. The a determines any like vertical stretch or compression. So if it's a number bigger than 1, it would make that graph taller and skinnier. If it's a number between 0 and 1, it would make graph shorter and wider. And then it would also determine if there is a vertical reflection. So if that parabola has gotten flipped over. So all of that is kind of included in A. And then H and K correspond to the vertex. So the vertex is HK. So that's why it's X minus H. You're taking the opposite sign. But that's going to be then also corresponding to the horizontal shift for the X coordinate and the vertical shift for the Y coordinate. So when we get the equation in this form where it's, this something squared plus something, so it's not like the standard form that's ax squared plus bx plus c. This form we can look at and the vertex is kind of right there. So it's just a matter of remembering which is which between the x and the y and which one has the sign change, which one doesn't. So in this case, if you know, it needs to be x minus h inside the square and then the plus k. So that would mean that h is 6, k is 4, and the vertex, it says type an ordered pair. So I'm using the parentheses and then the 6, 4, and there's the vertex. The axis of symmetry, it says type an equation. So that's one thing. It's got to have an equals in it and a variable. But the axis of symmetry is the vertical line through the vertex. So it's always going to look like the equation for the axis of symmetry is always going to be x equal to that x coordinate of the vertex, h. So in this case, x equals 6. But because it's represented as an entire line, just typing in 6 isn't enough. It has to be the x equals 6. All right, then we have the concavity. So concave, think of cave. You see that we're cutting cave there. So it's like the cave is the cave opening upward or downward. So you have that two possible parabolas. You have this, and that would be concave up. And then you have the concave down if it's flipped. And that's determined by whether you have something out front. If there's nothing out front of the squared part, A would be 1. And as long as A is positive, it's concave up. If A was negative, so if there was a negative sign or a negative number out front of those parentheses, then it would be concave down. All right, and then we have the graph. So let me clear off this writing here. And so this graphing tool, we have the 2-point parabola tool, the vertex and other point. So we're going to plot, we click on this tool, and we first have to plot the vertex. And so that's the 6, 6, -4. And you should be able to see up here, unless your instructor for some reason has taken that off, but you should be able to see the coordinates of the point that your cursor's on. And sometimes like the scale is weird or it's really small. So that can be helpful to make sure that you're at the right point. So there's the vertex. And then you need one other point, any one other point. So often if you just plug in, well, a couple things. If you just plug in an x value that's close to the x value of the vertex, so like 5 or 7 or something, plug it into the equation and see what it comes out. But the other thing is, if you look at the value of A, so in this case, A was 1, that number, there wasn't any number out front of the parentheses, so it's 1, then that tells you how far you're going to go if you go 1 unit to the right of the vertex. So I'm going to go 1 unit to the right, I'm going to go 1 unit up. If it was a -1, I would go 1 unit down. If it was 5, I'd go 5 units up, etc. So that's kind of a shortcut, or again, you can always just plug in numbers for x. If you get very far away from the vertex, they'll get really far and they'll be off the edge of the graph. So just pick a number close to the x coordinate of the vertex to plug in for x and evaluate to find a second point. Nope. All right, what did I do there? -6. Oh, it was 6 positive 4. But, okay. So 6, 4 for the vertex, and still up one unit to the right. That's where if I'd actually plugged in 7, I would have seen that needed to be 5. So that would tell me that, okay, I had the vertex wrong. But on the homework, you get those multiple tries. So you get it wrong the first time, you just keep trying again. And try it, like when it pops up, it'll give you sometimes, I didn't look too closely at that one, but sometimes it'll actually give you helpful information as to why it was wrong. So it can be worth reading those. Sometimes it's just like, you have the right answer, but you don't have it in the form that it needs to be, or things like that. So, all right. So that's that question. Moving on, I'm going to look at number 18. So here we have a function that is in standard form. And we want to come up with what are the transformations and what's the graph. We don't see, looking at the standard form, that doesn't really tell us anything useful about the transformations other than A. So we have 2 forms for a quadratic equation. The standard form has ax squared plus bx plus c. And vertex form is a times x minus 8 squared plus k. A is used in both because that's going to be the same number in both forms. H and K are the coordinates of the vertex, but also tell then the shifts happening. But B and C don't tell you anything really directly about the transformations. C is going to be the y-intercept, so that can be a bit of a shortcut. But that's about it. So we really need to get this into vertex form. The long way to do that is to complete the square, but there's a shortcut. So the shortcut is the x coordinate of the vertex, which is h, is found by taking negative b over 2a. And if you notice, that's just the quadratic formula without the square root part. So you don't have negative b over 2a on the formula sheet, but if you can remember, the quadratic formula is on the formula sheet. Then if you get to it and you're like, is it negative b over 2a, or is it, if you can't remember exactly what it is, look at the formula sheet, quadratic formula, throw out the square root part, and there you go. Now, you could have an additional formula to memorize for the y coordinate, but you don't need to do that. Once you have the y coordinate, you just plug the x coordinate into the function and find that y value that goes with it. So here we go. In this case, a is 4 and b is negative 8. So I plug in negative b over 2a, negative of negative 8 over 2 times 4 is 8 over 8, which is 1. So that's the x coordinate of the vertex. And then I plug in that into the function. F of 1 is 4 times 1 squared minus 8 times 1 plus 3. And that's 4 minus 8 plus 3, which is negative 1. All right. Now you might be saying, well, it's not asking for the vertex, it's asking for the transformations. Why are we finding the vertex? Well, once you have the vertex, those tell you the shifts that are happening. The left, we're shifting right 1, and we're shifting down 1. Because the original vertex would be at 0, 0. It's moved to the point 1, negative 1. So it's moved 1 unit to the right and 1 unit down. And then the 4 out front of the x squared, the a value, whether you're in standard or vertex form, that is telling you that the vertical stretch in this case is because it's bigger than 1. So I'm looking for stretched vertically by a factor of 4. It's not compressed, it's being stretched taller, not flattened out. So we need that. And then we need shift to the right 1. So not left, right by 1, right by 1, and then down by 1. So not up, but down. So the only one that has all of the right things here is C. Okay, and then we're going to be graphing this. So I'm going to clear everything off. I just have to remember that vertex was 1, -1. And we have that 4. So this graphing tool is going to be the transformation type graphing tool. So here I'm going to click the parabola shape, and then it just says click the graph. I click anywhere in the graph and it's going to start with the basic x squared. The vertical stretch compression, it even says here that's A. So I'm going to put in the 4. You actually should never be putting anything in the horizontal stretch of compression. Just completely leave that alone. Don't mess with it. But then we have the vertical shift, which even says is K. So that's the -1, moving it down 1, and the horizontal shift H, moving to the right 1. And then if there was a reflection, so if A was negative, you would have the reflection about the x-axis. You should never have a reflection about the y-axis for these, just the x-axis if A is negative. So there's the graph. Make sure I didn't mess that one up. All right. So that's the other graphing tool you'll have in this section. All right, I'm gonna look at number 22. So this is another, it's in standard form, but we're gonna answer various questions about it. So starting with, does the graph open up or down? So that's the same thing as the concavity question. It's just asked a little bit different way. Again, it's going to depend on is A positive or negative. So starting out here, I have -x squared minus 8x. So A is -1, B is -8, C is 0. Just to kind of get that settled. So A is negative. That means it's going to open downward. All right, that adds the coordinates of the vertex. So I'm going to do HK, where H is -b over 2a, and K is the function value found by plugging in H. So -b over 2a comes out 8 over -2, so -4. And then I plug that into the function. F of -4 is negative square of -4 minus 8. Lots of minus is going on here. -16 plus 32. So it comes out positive 16. So there's the vertex. All right. And then it wants the axis of symmetry. So again, that's just going to be x equal to the x coordinate of the vertex. Just don't forget the x equal. And then we want the x-intercept. So x-intercepts is you set it equal to 0 and solve for x. And so I'm going to factor this, but first I'm just going to switch sides on everything. So I'm going to make this x squared plus 8x equals to 0. Just makes the factoring a little bit simpler. So x times x plus 8. Make sure you get both of those solutions. Then we have a 0 and we have a -8. And it seems to be a tendency to want to miss one or the other of those. So we have these two x-intercepts, 0 and -8. Not typing in an ordered pair, not putting parentheses. It's not 0 and -8. And 1 point, it's two separate points here. So if I was sketching the graph here so far, I would have the vertex at -4, 16, somewhere up here. And then I'd have now x-intercepts at 0 and at -8. The vertex is always going to be exactly halfway between the x-intercepts. So if you get x-intercepts that don't match up to where the vertex is halfway between them, something's gone wrong. Then the y-intercept shortcut, y-intercept is C. So if you know what the C value is, that's the y-intercept, or you can plug in 0 for x if you need to figure that out. And the other shortcut is once you have an x-intercept of 0, that's also the y-intercept. All right, so then graphing, we're using, again, this time the vertex and other point. And in this case, I have the vertex was -4, 16. And then I have several other points to go with. I have those x-intercepts and y-intercepts, so I just need to pick one of them to plot to get the whole graph. And then it asks for the domain. The domain for a quadratic, always all real numbers. You don't have to do any calculation or thinking about it. Just make sure that you know how to enter all real numbers in interval notation, going from negative infinity to positive infinity, enclosed in parentheses. For the range, the y-coordinate of the vertex is going to be the endpoint of the range with square bracket. And then you just have to figure out, is it going from negative infinity up to that point, or is it starting at the point going to positive infinity? In this case, we're going from negative infinity up to that 16, that y top point with square brackets there. And then ask the functions where the function is increasing and where it's decreasing. So looking at this, it's increasing until it gets to the vertex. So the x-coordinate of the vertex is where it switches. So from negative infinity to -4, increasing, and then from -4 to positive infinity, now it's decreasing. So, and let me just check. I think it'll accept that with square brackets or with parentheses. Yeah, so if you want to use the square brackets, the parentheses are technically more correct, but the square brackets just help make it clear that this is not an ordered pair. The infinities also make that pretty clear. So, so that's that question. That's the most parts you're going to get in a question on these, and it is, it's 10 parts, but that's still, you had a lot more than that in some previous sections, so hopefully fairly doable. So I'm going to go now to number 24. And I am keeping an eye on the chat. If you do have questions, I know I'm going pretty fast, so if you don't have time to type your question, at least like throw some question marks in the chat or something. But here we're given the graph and we want to come up with the function. Now, it doesn't specify what form that function needs to be in. So the easiest way to do is to keep it, we're going to use vertex form to start with. So unless it absolutely says put it in standard form, leave it in vertex form. That's going to be easier and avoid introducing errors and trying to convert from one form to the other. So again, you need to know the vertex form y equals a times x minus h squared plus k. H and k are the coordinates of the vertex. But then where does a come from? To get a, you have to plug in x and y from some other point, and that will then allow you to solve for a. So I plug in the vertex. So I'm so far going to have x, and so we have h is -3, k is 5. So it'll be x plus 3. Don't forget the squared. That's going to mess things up if you leave that out. And then plus 5 out here. And then we have a. So to figure out what a is, I'm going to take this other point that I have. In this case, I have 0, -4. And I plug the 0 in for x, the -4 in for y. So -4 equals a times 0 plus 3 squared plus 5. Plugging in again 0 for x, -4 for y, solve for a. -9 equals a times 9. So a equals -1. So I can just put a minus out front of that. But that's the process when you're asked to write an equation. Again, unless it absolutely specifies, put it in standard form. You're really better off leaving it in vertex form. So that's the process to write a quadratic equation. And then that brings us to inequalities. So going to number 32. So I have this graph here of a parabola that's f of x and a straight line that's just g of x. And I'm being asked to solve these inequalities. So the first one is g of x greater than or equal to f of x. What I'm looking for is the set of x values for which g of x is greater than or equal to f of x. And the solutions are going to be intervals or arrays, and where they end is at the points of intersection of these two functions. And those are even already labeled for us. So we have the -5, 16 and the 1, 4. So that means if I look at the graph between -5 and 1, the line is above the parabola. So for that part, g of x is greater than f of x. So that's the interval from -5 up to 1, if I look at those x values that are included there. Then from 1 to infinity, we have the line below the parabola. So g of x is less than f of x. And also on the other end, from -infinity to -5, the line is going to be below the parabola because there's nowhere else that they're going to cross. The parabola isn't going to turn back and cross the line again. So looking at the answers, then we want where g of x is greater than or equal to f of x. So I've done open intervals here, but then the endpoints will get included if if necessary. So if I look at this, where g of x is greater than or equal to f of x is going to be the interval from -5 to 1, but also including actually those points of intersection where they are in fact equal. So that's the first part. Going from -5 to 1, so between those 2 points of intersection, including the intersection, but again, just giving the interval of x values. And then it asks where f of x is greater than g of x, and that's going to be those outside parts where the parabola is above the line. So going from -infinity to -5 with parentheses, because now it wants to know where it's actually greater than. And at -5, they're equal. So that one is not included. And if it just says interval notation and it doesn't say anything about commas, then you need to use that union symbol, not a comma in between, because then we have that second interval from 1 to infinity, where it's also the parabola is above the line. For all of these quadratic inequalities for the whole section 4, 5, you're typically going to have possibilities. You'll have 3 intervals, and you'll either have the middle interval or the 2 outside rays. Those are pretty much what your solutions are going to look like, other than if those if the x-intercepts kind of merge down into a single point, then you could have a single point as a solution value, or if the whole, if it's all the way above, you could end up with no solution or all real numbers. But most of the time, it's going to be the middle interval or the 2 outside. So check that. Yeah, good. So then I want to look at number 38. And here we have 2 functions, but we're not looking at the graph. We're just given the functions and given a bunch of different inequalities to look at. So I'm going to do this general process because this is going to apply also to section 5.5. So the process is this. Step 1 is you want to get one side. So this is kind of an if necessary, rearrange to something or other, and then with 0 on the right side, basically. So however you want to write that down, you want to get it to where one side, the right side of the inequality is 0. Step 2 is to factor the left side. And then here's where it's going to be different from what you've done. If it's an equals, you would split it into separate equations. You're not going to do that here. At this point, you're going to not even think of it as solving an equation or solving an inequality anymore. What I recommend doing at this point is make a number line. And you're going to mark the zeros, the points corresponding to each factor. And then on that number line, you're going to figure out kind of what the graph is doing. So those marks from step 3 divide the number line into pieces, and you're going to determine whether the graph is above or below the x-axis. So above would be greater than 0. Below would be less than 0. So this is something you were already asked to do as a tiny part of those giant rational function questions. And now sections 4.5 and 5.5 are basically devoted to this process of where is it above the x-axis, where is it below the x-axis. And then the last part is to kind of figure out what the actual solutions are. So identify which of those pieces actually go into this solution. Now, with quadratics, this step 4, you can kind of shortcut by just figuring out it's going to be a parabola, either it opens up or opens down. And then you want to think about, you know, if there's 2 factors, then those are the 2 points. But depending if it doesn't factor, or if it factors to a perfect square, then that's going to be a little bit different. So starting with here, then f of x equals 0. So that's just an equation. So we're just looking at really finding where those x-intercepts are. So that's going to be same as x squared equals 9, and that's plus and minus 3. So I have -3 and +3, and I'm kind of already then at step 3 if we have the number line. So solving the equals 0 gives you the points on the number line. But in this case, the solutions then is just those 2 x values, which can be given in any order. When you're doing intervals, it has to be the right order. So g of x equals 0. That's, again, just an equation that you're solving. So that's going to be -9/6, -3/2. So that shouldn't be, those first ones should be just old process that you already know how to do from previous courses even, or previous sections. F of x equals g of x. Again, it's just an equation. So we're setting -x squared plus 9 equal to 6x plus 9. The 9s cancel out. I'm going to actually add x squared to both sides. So I get x squared plus 6x equals 0. Factor that, x times x plus 6 equals 0. And again, make sure you get both solutions then. There's a 0 and there's a -6. So each of those factors, the x is a factor that has a solution associated with it, and the x plus 6. All right, so then we start getting the inequalities. So I have, for f of x, if I look at f of x, we have a negative a value. So that's going to be a downward opening parabola, and it's going to cross at the -3 and the +3. So we have the graph above, so greater than 0 or positive, however you want to note that to yourself, in the middle, and then negative below, less than 0, below the x-axis on the outside pieces. I tend to just use a minus and plus to mark those, so I'll do that going forward whatever time we have left. So we're looking for where f of x is greater than 0. So it's strictly greater. So we're going to have open intervals, and we're looking for that positive piece. So that's the middle piece. So this is going to be the interval from -3 to 3. So now definitely thinking left to right, interval notation, parentheses, -3, 3, parentheses. And here, if I did the opposite order, did the 3 first and then the -3, that would be wrong. All right, g of x is less than 0. G of x now, we have that one intercept, where it crosses. G of x is a line, so it's a diagonal line, and it's crossing the x-axis. We said at -3 halves. It has a positive slope, so I know it's going up. So that's all that really I need to know about to say where it's less than or equal to 0 is on this part, including actually at that intercept. So going from -infinity up to the -3 halves, and then with a square bracket because it said less than or equal to. All right, then we get, what about where f of x is greater than g of x? Well, we already figured out that f of x equals g of x at 0 and 6. So if we look at these two graphs together, we have the parabola, and then we have the line, and their intersections, which I probably drawn this wrong, but all that really matters is that these are at -6 and at 0. Between those intersections, the parabola f of x is above. And then on either side, the parabola is below. So we're looking for where f of x is above. That's going to be that middle piece between the intersections. So between the -6 and 0, it's just a greater than, not a greater than or equal to. So using parentheses. Then it asks where f of x is greater than or equal to 9. So now my previous calculations aren't really going to be helpful. I'm going to start over, just setting f of x. So -x² plus 9 is greater than or equal to 9. That's what I'm solving. Now I'm going to follow this process. I want to get 0 on one side. Subtract 9 from both sides. So I want to know where -x² is greater than or equal to 0. Now, I'm not going to just solve this like a equation. I'm going to look at, kind of step aside and say, where does -x² equal 0? Well, that's going to be just at 0. That's going to be my divider then. So I'm going to have these two possible intervals, 0 to infinity, -infinity to 0. 0 itself may or may not be included. Now, -x², if I just look at the -x², that's a parabola opening downward. So I have this, so it's below on the right side. It's also below on the left side, or negative. Less than 0 on both sides there. Of course, at 0, it's actually equal to 0. So I am looking for where it's greater than or equal to 0. It's not greater than or equal to 0 on either side. At 0, it's equal to 0. So the only solution here is just that single value 0. And you kind of have a hint to that even with it having the curly braces, indicating you're going to be listing individual values rather than an interval. But only at 0 is that actually does that actually work? All right, so that was the last one. So that's about the weirdest it gets, is when it's just that single point solution. So that's it for what I plan to talk about. Any other questions from 6 or from 5A homework? Hopefully anything you got stuck on one of those questions I went over helped figure that out. So in the remaining time, I know I didn't give you any time to actually say if you have questions, but shout out if you do. But I'm going to switch over to section 5B and look at some questions from there. All right, so I'm going to start with number 2. So here we're doing inequalities where this is more going to follow those steps that I wrote out and now erased. So, but when you're looking at a graph, what you want to look for when it's rational and polynomial, you want to look for, you want to split the x-axis. You can think of it as your number line at every x-intercept and vertical asymptote. So here, that's going to correspond to factors of the numerator and denominator, but we weren't given the actual function here. We just have the graph. So I need to look, we have x equals -2 as an asymptote. We have an x-intercept at 0. We have x equals 1 as an asymptote. And that, I think, is all of them. I'm going to try and on this graph a little bit more. So that gives me my intervals. I have from -∞ to -2. I have from -2 to 0, from 0 to 1, and from 1 to infinity. And I can tell visually looking at the graph, we have this piece that's above, and then it's below here, and then it's above again, and then it's below on that far right part. Below being less than 0, above being greater than 0. So when it's looking for f of x less than 0, the less than is easy because it's always going to be parentheses, no square brackets. So I'm looking for the below pieces, so -2 to 0. It doesn't say anything about commas, so I'm going to use that union symbol. The other below piece is from 1 to infinity. For the less than or for the greater than or equal to, I want the above pieces. So the -∞. So the infinity always has parentheses. The -2 was an asymptote. So asymptotes are always going to use parentheses no matter what the inequality is. So union. Then we have the 0 to 1, but the 0 is an actual intercept. So at 0, the graph is in fact equal to 0. So that one does need to be a square bracket because it was greater than or equal to. The 1, again, is an asymptote, so it's going to be a parentheses. So you have to watch with the rational, the brackets versus the parentheses. If it's an intercept and it's a greater than or equal to or less than or equal to, it's brackets. Any other asymptotes, always parentheses. Infinities, always parentheses. So you just have to watch for that. Then I also want to look at number 3, and I kind of want to look at, even though it only asks greater than 0, look at all the possibilities. So we have here these two x-intercepts. So we have 0 and we have 2. So we have the intervals from -∞ to 0, 0 to 2, and 2 to infinity. And we have the graph above the x-axis from -∞ to 0, also above from 0 to 2, because that was just touching there, and below from 2 to infinity. So if I'm looking for just greater than 0, that's not going to include, so I'm going to put all these possibilities. We have greater, we have less, we have greater than or equal to, less than or equal to. The greater than aren't going to include the endpoints. So greater than or equal to 0, I would need to include the -∞ to 0 and 0 to 2, but leaving out the 0 itself. Less than 0 then would just be the 2 to infinity. But if I go the greater than or equal to 0, now I get to actually include 0 itself, and that kind of merges those separate intervals. So I would just go from -∞ all the way to 2. On all of that, it's either greater than 0 or equal to 0, so they're all included. For the less than or equal to 0, then I include the 0 because there it's equal to 0, but it's now all by itself. I have just this one point where it's equal, and then the 2 to infinity where it's below. So those are kind of all the possibilities you might have when there's an intercept where it actually touches the x-axis. It might just be included all by itself as an isolated point. It might just merge those intervals together, or it might just be excluded and have those two separate intervals, but all that's being excluded, we have the 0 on the one end and the 0 on the other end, but it still has to split into two. And that's what we actually had on this specific question, was where just the 0 itself is being left out. And then of course, everything above 2. All right, so then I wanted to look at number 17. And the main thing I want to look at on this one is just when we had rational equations back, I'm not sure if we even did that, but your instinct might be, when you see something that looks like this, is to kind of cross multiply and get rid of the denominators. When it's an inequality, you should not do that. You can't do that. So it gets more complicated. We have to actually just move everything over, still following that steps that I said, get one side 0, but you don't want to lose any of the denominators. So I'm going to subtract the 4 over 5x minus 35 from both sides. And that means I now need to combine these into a single fraction. Again, I don't want to lose the denominators. So I'm going to multiply the 1 over x minus 4 by 5x minus 35 on the top and bottom, and the minus 4 by x minus 4 on the top and the bottom. So my denominator for everything is going to be x minus 4, and I'm going to go ahead and factor out the 5 because it's just kind of complicating things, and that's an x minus 7. But I end up then with 5x minus 35 for the top here, and then this is going to be, if I distribute the whole, -4 minus 4x and then plus 16, and then I can combine those. So I end up with x minus 19 on the top here. So now each of those factors, so I have a 19 and a 4 and a 7. The 5 doesn't count as a factor in this case because there's no x in there. So 19, 4, and 7 are the values that are going to make this whole thing either undefined or equal to 0. So I'm going to mark those, make sure they're in order on the number line. So 4, and then 7, and then 19. And I'm going to mark some other things. So I'm going to put a dot at the 19 because that's the actual intercept. So I know that one could potentially end up with square brackets. I'm going to just do a little bit of a dotted line at the 4 and 7 to remind myself those would be the asymptotes. So those have to always have parentheses. And then I'm just going to check and see if any of those factors were squared. And none of them were. So I'm just going to make a note to myself, opposite, which is my way of reminding myself that it's going to switch from positive to negative at each of those. If the factor was squared, it wouldn't switch. It would be the same on both sides. So that can kind of shortcut. So I don't have to do a test value of every single interval. But the intervals I'm looking at then, I'm just going to do these all with parentheses. That's what it's looking for, because I don't know for sure yet whether the ends are going to be included or not. In fact, in this case, it's strictly less than, so none of them are going to be included. But I'm going from negative infinity to 4 for the first interval, from 4 to 7 for the second interval, 7 to 19, and 19 to infinity. And then I just have to figure out, since I know it's going to alternate because none of these factors were squared, I really only need to test one value. And usually the easiest thing is to look at what if x gets big enough. So if x is big enough, what's going to happen? The x minus 19 will be positive, the x minus 4 will be positive, the x minus 7 will be positive. Once I get bigger than 19, everything's coming out positive. So I know that far right piece is positive. And then again, since none of the factors are squared, it's going to alternate. So then I can put in, if you're more comfortable doing test values for each interval, certainly it's fine to do that. But if you can figure out those shortcuts, it'll just save you some time. But yeah, make sure that you're getting, getting those zeros of the top and bottom in correct order, left to right. So I'm going to look at another similar question to this. So number, this is number 19. What is the solution? Okay, so yeah, we're looking for the less than, so looking for the negative. So negative infinity to 4 and 7 to 19. All right, so number 19, similar as you set it up with these intervals. Here it's already 0 on the right side, so I don't have to do any extra calculation. I can right away say, all right, I have my x squared, so that's a 0. The 2 plus x equals 0 when x is -2. X plus 6 would be a -6, x plus 7, -7, x minus 1, 1. I need to get those in correct order on the number line. So -7 comes first, then -6, then -2, then 0, then 1. Notice I'm not even worrying about this correct scaling. I'm just getting them in order. And I need to figure out, so I'm looking, the -7 came from the bottom, so it's an asymptote, as is the 1. The others are intercepts. I'm noting that. And then I'm looking for any squared factors, and the x squared, that's squared. So at 0, it's going to be the same on both sides. All the other factors aren't squared, so they're all going to switch and be opposite. But I'm jumping a little ahead. What they want first is just the intervals. And even though it's looking for greater than or equal to, for these intervals so far, we're just going to put them with parentheses, so the open intervals, and then we figure out later whether the endpoints get included or not. So -infinity to -7, -7 to -6, parentheses, not a 0. And then -6 to -2, and -2 to 0, 0 to 1, and 1 to infinity. All right, now I can figure out, again, if I know the shortcuts and use whether that factor is squared or not, the multiplicity to figure out, all I need to do is find one sign to start with, and that'll tell me all the others. And again, that farthest right, usually the easiest one. If I put in something bigger than 1, the x squared is positive, the 2 plus x is positive, the x plus 6 is positive, the x plus 7 is positive. And as long as I'm bigger than 1, the x minus 1 is positive, everything's positive. So that far right would be positive. At 1, it switches. At 0, it doesn't switch. Everywhere else it switches. So plus, then minus, then plus again. If you want to test values to double check, I recommend you at least be aware of those shortcuts so you can either use them to kind of check and make sure your test values are working, or or just use them without test values. But positive, negative, positive, negative, negative again, positive. So then we need to figure out the actual solution. So we're looking for where this is greater than or equal to 0. So that means that x-intercepts, those get included. So any of those, the -6, the 2, the 0, those would all be square brackets. We're looking for the positive pieces. But then we also have to watch if we have the 2 square brackets next to each other. So at 0 itself, maybe just put the equal at each of those, even though it was negative on both sides, at 0 itself, it is equal to 0, so that counts. So we're looking for the -infinity to 7. So all of these options have that. But we want not square bracket on the 7, we want parentheses on the 7, because that was from the bottom of the fraction. So it was an asymptote. It is not equal to 0 there. It doesn't actually exist there. Then we want the -6 to 2 with square brackets on both sides. So not parentheses. And then we do need the 0 included. So this one is missing the 0. So we do need the 0. And then the 1 to infinity And so that narrows it down to just A as being the only one that has brackets where they should be, not where they shouldn't be, and has that 0 included. And all that. So those are about the most complicated it gets, where you have kind of that isolated point mixed in there. You have the mix of intercepts and asymptotes and all of that. All right, so I'm going to wrap up with one question from section 5.6. So I'm going to go to number 31. So 5.6, we're looking for all real solutions to a polynomial. So your process is something like this. What I would recommend, you'll have various other details that you'll be asked to look at that can be helpful, but really aren't necessary. So I'd say first thing is to see if you can factor. In this case, particularly factoring by grouping. The second thing, if it won't factor, is to determine all the possible rational zeros. Now, you're looking for all the real zeros, so it may or may not be rational, but the shortcut, the way to figure out what to test, is all possible rational zeros. I'm kind of assuming, for sake of time, that you, as you're listening to this, or as you're watching it again later, that you have some idea of what these are. So then you would start testing. And I would recommend using synthetic division for that. There's other ways to test, but the advantage of the synthetic division is when you find one that works, you've not only found that that one works, but you've found what's left when you factor that out. All right, so I'm going to skip step 1 here to see what happens if I don't factor by grouping. And so the possible rational zeros, you're going to look at the factors of the constant term. So that would be 1, 2, 7, and 14 in this case. And the factors of the leading term, in this case, 1 and 3. And you're going to divide. So I have 1, each of these over 1 would just be themselves. So 1, 2, 7, and 14. But then I also have 1/3, 2/3, 7/3, and 14/3, and I have plus and minus of all of these. So I have a total of 16 possibilities. Still, that's better than all the possible rational numbers in existence. Narrow it down from infinity to 16. So I'm going to set up my synthetic division. So I have the coefficients 3, -2, -21, and 14. And I pick one of these to start with. So I'm going to start with 1. And so I drop down the first coefficient, multiply, add, multiply, add, multiply. I can tell this doesn't work. So I know +1 is not a 0. I'm going to try +2. So drop down, multiply, add, multiply, add, multiply. That did not work. So 2 doesn't work. I'm going to try 7. So drop down, multiply, add, multiply. That's going to get way too big. That I know that's not going to work. I'm going to go the other direction and try -1. So drop down, multiply, add, multiply, and closer there. I'm going to try -2. So add, multiply, 16. That's 10. So it doesn't work. -7. That's getting way too big. All right, so maybe it's one of those fractions. I don't know, but so just the testing process, at most I would have to test 16, but I'm going to back up to that step 1 that I skipped over. Does this factor by grouping? And I look at the first 2 terms and I can factor out an x, and I'm left with 3x minus 2. And then from the last 2 terms, I can factor out a minus 7, and I'm left with, or sorry, I'm factoring out an x squared from the first 2 terms. So x squared, factor out, leaves 3x minus 2. A 7, negative 7 leaves 3x minus 2. Those match. That's the thing that has to happen for this to work. So my factors are x squared minus 7 and 3x minus 2. And now I can see I would have had to test positive 2/3 to work for that one. For the x squared minus 7, that's going to be x squared equals 7. That's not even rational. Plus and minus square root of 7. Those are real solutions, but they're not going to come up in any of the rational. So in this case, remembering to try to factor by grouping can save you a lot of time if it works. So 2/3, and then square root of 7. And I'm not sure if it lets you do plus or minus on this. Let's see. Yeah, okay. But that's the process you can use. There's also some other things. There's the Descartes rule of signs. There's finding upper and lower bounds, intermediate value theorem. But as far as just actually finding the solutions, the one other thing you might be asked to do is sometimes you're asked to find the solutions. So that would be finding those values, but you also might be asked to factor. So once you find those solutions, if you've just been doing the synthetic division, if my solutions are 3 and -2 and 1/3 and 5, then the factors would be x minus 3 and x plus 2, and the 1/3 wouldn't just be x minus 1/3, because you wouldn't have fractions typically. That would get multiplied through by 3, so it'd be 3x minus 1 and an x minus 5. So those zeros go into factors that match up with them. So hopefully the Friday and Saturday sessions then will probably go into a little more examples in detail on these module 5B problems, but hopefully at least you have some idea. There's also a graphing tool where you have to find 4 different points to graph a cubic function. There's so various other things here, but I am out of my time. So any questions from any of you before I close this meeting? Oh, let me go to, go ahead then, please, if you can, go to this feedback form and let us know you're here. Let us know what we can do better. And we know it would be nice if we could do these for longer, but this is all that we have kind of permission to do right now. But knowing that you would like them to be longer is still good information for us to have for the future of this whole thing that we're doing. So, but yeah, any of that feedback that you've been giving, keep doing that so we know that you're here and know how it's working for you. I'm going to go ahead and stop the recording at this point, and then